Welcome to qnawire.
Okay, so we have the following molecule, wedge to methyl, and a dash to an iodine, and we're reacting it with sodium hydroxide and heat. And recall that sodium hydroxide is a strong base, which means if we're talking about an elimination reaction, we have a strong base, then we're talking about E2, which means that we need to find a hydrogen which is anti to our leaving group. Our leaving group here is iodine, so let's draw in the hydrogens on the neighboring carbons. We've got a hydrogen down below this methyl group. We've got over here, we've got a hydrogen pointing up, as well as a hydrogen pointing down. I'm going to actually use a different color for this hydrogen. Now, what am I talking about when I say anti? Well, remember that for an E2 reaction to happen, we have our leaving group. If that leaving group's on a wedge, then we need our hydrogen to be on a dash. Likewise, if our leaving group is on a dash, then we need our hydrogen to be on a wedge. So if we look at our leaving group here, iodine, it's on a dash, so we need our hydrogen to be on a wedge. We cannot form a double bond on this side because our hydrogen is not oriented properly. We need it to be on a wedge and not a dash. Over here, however, the blue hydrogen is on a wedge, which is anti to the iodine, which is on a dash. So the only side that we can form this product on would be this side. And so, in fact, the mechanism for this will look like as follows. I'm just going to grab the hydroxide, not the sodium, but nevertheless, the hydroxide will come and grab the hydrogen. The carbon-hydrogen bond will get left behind to form the double bond, and our iodine will leave. And so our final product will be, we'll still have our wedge to methyl here. We no longer have an iodine there, but we do have a double bond between those two carbons. And if we look at the options here, that is 1, 2, that is the third option.